Good morning. Can you hear me? Somebody please respond.
Yes, sir.
Okay, the voice is clear.
Sir.
Okay. Okay, then we would start. Please let me know whether the voice is clear in chat box. Okay. Okay, then we will start. So last class we were discussing about Horton's equation. It is in respect of infiltration. So a Horton equation consists of an equation of this kind, wherein the value Fp, lowercase fp, represents the infiltration rate at any instant of time. And similarly, Fc, lowercase fc, represents the infiltration rate which has become steady or constant after some time lapse from the beginning of the rainfall. Then F naught is the beginning value of the infiltration. So F naught, infiltration in the beginning, Fc, constant value of infiltration in the end, and Fp, at any instant of time, what is the value of infiltration. So based on this, for the time duration 0 to Tc, that is Tc is nothing but the duration up to which the recordings are taken. So that is the final limit or the maximum limit of the time what we are considering. So based on these things, we would go ahead with an equation which also has Horton's coefficient Kh. So that is also written here, Horton coefficient Kh, e to the power Kh into T. So based on this, let us look at the example which we already discussed in the last class, but we are yet to do many more questions related to this. So I will start from the beginning once again, just for clarity. What is that we need to do? So this is the infiltration data obtained from double ring infiltrometer. That is, time is recorded in minutes here, and cumulative value of infiltration is also given. I remember one thing, cumulative value is indicated by uppercase FP, whereas the infiltration rate is lowercase fp. So this distinction you should be very clear. Now what I would do is that to take care of this example, I will take the initial data as it is. What is that we are required to do based on this? So I will copy it onto an Excel sheet. You have to do it in examination using graph sheet. So time, so I will just say time in minutes for this. Then for this one, cumulative infiltration depth, that is just uppercase FP. We will write that uppercase FP, right? Uppercase FP. So this is what we have for the purpose here. Time in minutes it is, right? You remember this, time in minutes. So I am just making it little short such that you will all see everything very clear. Time in minutes. Okay. So now the statement of the problem we will look at. So we have to do a lot of things. In examination, you may have to do only one of these things. But for the sake of generality and also to understand all aspects related to infiltration, we are doing everything for a single problem. In examination, any one of this may be an issue for you. So here we have to plot a graph of FP, infiltration capacity against time. Then another graph of cumulative infiltration FP against time. Then another graph FP versus FP, infiltration capacity versus cumulative infiltration. Then finally, time T against natural log of FP minus FC. So all these things need to be done. Why we have to do this log on y-axis? We will discuss this while solving this example. Now to begin with, let us concentrate on T versus FP. Please remember one thing, T comes in x-axis, independent variable, and infiltration rate or capacity small fp comes in y-axis. T is independent, FP is dependent. T on x-axis, FP on y-axis. So based on this, here we have cumulative value of infiltration. This is cumulative. So I need to write that also here, cumulative. So based on this, we have to determine infiltration capacity. For that, the time intervals you have to know. So the duration. See, if you look into duration, look here, 0 to 5 minutes, 5 to 10 minutes, 10 to 15. So these are all intervals of time. Therefore, the interval starts from here. This is 5 minus 0, 5 minutes. The next one, 10 minus 5, again 5 minutes. Like that, you calculate all intervals of time. That I would do. Look here, the intervals of time has not remained constant. It has changed. The first 3 intervals are 5 each. Next you have 10, next 20, again 15 for 3 more instances, and finally 20 and 20. So this duration is again in minutes. You may have to understand this. This duration is again in minutes. Then further, the value of infiltration. So the infiltration value, so that is cumulative infiltration is given in centimeter, so as this is also in centimeter. So here, this is given in centimeter. If you look into the problem, this is mentioned in centimeter. You can just go back to the problem and look at that. See here, it is given in centimeter. I am also taking it in centimeter. So once you have this in centimeter, then you calculate the quantity of infiltration for each interval of time. So for the case, first case, it is 1.75 minus 0. For the second case, it is 3 minus 1.75. Like that, you will calculate for all other instances. I'm doing it here. Job is easy with Excel, but in exam, you will use calculator for this. This is done. Now, time, cumulative FP, duration, time duration in between these instances of time, then infiltration, which has happened during 5 minutes, during 10 minutes, during 15 minutes, during 20 minutes, etc. are also calculated. So based on this, the infiltration capacity small fp in centimeter per hour needs to be calculated. In centimeters per hour needs to be calculated. You have to be very clear about this. FP in centimeter per hour needs to be calculated. So how are you going to do this? So first you have to do this time. You have to convert this time in minutes to hours. So that I would do it here. Look here. So here, this is equal to each hour is 60 minutes. 60 minutes divided by the duration is 5 minutes. The depth of infiltration is 1.75. So it gives you the infiltration at this instant as 21 centimeter per hour. And similarly, for the next case, what I would do is I will do the similar thing. 60 divided by the duration, again it is 5 minutes, then multiplied by infiltration depth, you get infiltration capacity in centimeter per hour. So similarly, you would calculate for all other intervals of time. So that is done here. This is done. Okay. Any doubt at this stage regarding determination of
No,
FP?
sir.
FP clear?
Yes, sir.
Okay. Then you remember one thing, towards end here, the value 3.24, 3.24 repeats. Therefore, this value is nothing but the constant value of infiltration. 3.24 is constant value of infiltration, which we are discussing in Horton's equation. So this is something what we need to do. And similarly, now the requirement as per the problem here. One second. Yeah, down below. Now, a plot of time t versus infiltration capacity Fp. So this needs to be done. So Fp t versus Fp. So first graph is t versus Fp. This is time t. Then this is Fp. So I would plot this in Excel itself. You just have a look. Insert. The graph has come. Look into this. So this is a graph of T versus small fp, that is time versus infiltration capacity. Okay, then the axis titles needs to be given. So you may have to talk in terms of axis titles. So what you have to do is that axis title in the exam horizontal, this is time in minutes, you would show, then vertical. Here it is infiltration capacity in centimeter per hour. So that I have put here. Yeah, infiltration capacity in centimeter per hour. This is all you need to do. But I would go one step further. Just because we are using this Excel, you can even derive an equation to fit this plot. A best fit trend line can be obtained. This is useful for us to understand little later when we talk of plotting the values on semi-log sheet. So I will take the same data, I will add a trend line, a power series to this. Look here, the power series is the dotted line which exactly matches with this. And if I wish, I can get the equation of this also for my purpose, for our purpose. I will display the equation here. The equation of the power series has come. So look here, it is 60.179 x to the power 0.621. That means to say that, 1 second, I will make it a little bigger such that you will all see it better. Okay, so this is the equation of the power series. What y and x represent here? Here, y is a dependent variable, that is infiltration capacity in centimeter per hour. Whereas x represents the time in minutes. For example, you just go back to the problem. For 60 minutes and 75 minutes, you have the value of infiltration capacity 4.2 and 4. We have calculated between 60 and 75. It varies from 4.2 to 4. Suppose if you need the value of infiltration capacity at the instant of 65 minutes, it is not in the table, which you can easily obtain using this equation. Just to illustrate that, see here, suppose if you substitute x as 65, you will get the value of y. That I would do it here. This is equal to 60.17 star the value of 65, right? And then exponential, star exponential. 1 second, somebody wants to get in. Yeah. Exponential minus 0.621 will determine the value of infiltration capacity at time 65 minutes. 1 second. 1 second. $60.179 star. 1 second, just a second. In hour, I have to substitute. Sorry, I just made a small mistake because this is taken in hours, right? So I should have taken it to 65 minutes. 1 second. 65 minutes divided by 60, so many hours. This is equal to 60.179 star. In hours, I have to indicate 1.08333 star exponential minus 0.621. So if you do this, 1 second, minus sign has not come. 1 second. I want to admit one more person. 1 second, just be online. Yeah, just be online. 1 second. I will just take attendance for a while. Just allow me some time so that I can take few snaps. Now that everybody has come, I will take few snaps and then continue. 1 second. One second, please be online. One second. One second, not done yet. Okay. Okay, so we have done the first part of the example here. I will come to this equation check once again. We have to redo this once again. Then let us look at the other part, time versus cumulative infiltration FP. So we need to plot this. then what you need to do, so you have to take this time okay, then this FP, you have to take this, you have to plot this graph. Look here. So this represents time versus uppercase FP. And again, here the axis has to be mentioned. Axis title, primary horizontal, time in minutes, time in minutes, and similarly, primary vertical, cumulative infiltration in centimeter. So that also is done. So this represents the second part for us. This is the first part. What you have is the first part, that is time versus infiltration capacity. And the second part is time versus cumulative infiltration. Then the other one, FP versus FP, cumulative value of infiltration against infiltration capacity. If you wish to do that, you have to do it by choosing appropriate values. Now I select FP and then this infiltration capacity. So both I would select, then I would insert, go to this. So this represents a graph of FP versus lowercase fp. This represents that. And then what is that you have on axis? Horizontal is fp. We may be running out of time in 10 minutes. Till then we will continue. And after that, you please rejoin with the same link. So axis title, primary horizontal. So you have FP, that is cumulative infiltration. That is done here. 1 second. 1 second. Axis title, primary horizontal, FP, cumulative infiltration. That has come here. Look here. That value has come. Cumulative infiltration. Similarly, the vertical axis, you have to show that also in exam. That is the value of infiltration capacity, small fp. Capacity in centimeter per hour. That is also done here. See here. And if you wish, you can have a best fit even for this also. Now, the most important thing for us here is, if you go back to the problem, is this last part. This is very important for us. In the examination, the first two parts are very simple and straightforward, which you can easily do it. And you need not derive any equation for that. You just plot the graph and end with that. But why do we need this? Why do we need this? That is a question. So we need this for the reason that when you use graph sheet, if your plot appears to be in this form, and for which the best fit is a power series, you will not be able to easily derive mathematically the equation related to this. In most of the cases in engineering, what we do is that any nonlinear variation of this kind is made linear to obtain data easily by plotting. A nonlinear situation can be made linear on a semi-log or log-log sheet. A similar attempt can also happen for this case of Horton's equation. Suppose if you look into this Horton's equation, if you look into the original Horton's equation, if you take log on both sides, log fp, log fc, log of f naught minus fc, then in which case it represents e to the power kht. If you take log, then it represents an equation for a straight line. It represents an equation for a straight line, because of which it is very easy for us to derive the decay constant kh, and then having an explicit relationship for this fp. It is easily possible. So I will show you how it can happen. For example, if you wish to plot this one as a problem statement, first we will do this. Time t versus fp minus fc. See, this, if you wish to do it, what we are required to do? First of all, in the problem, the time I would take, I will show it separately. For Horton's equation, you please remember what needs to be done. I will go a little below. I have taken the time. This is time in minutes. Then for Horton's equation, you convert time into hours. Again, I will convert this into hours. So how we are going to do that? This is nothing but you divide all these values by 60. So I will convert the same time into hours. Of course, you can truncate these hours time into 3 decimal locations, which I will do in examination. You need not carry this so much. So time in hours, first time in minutes, you convert that into time in hours. If it is already provided as time in hours, you keep it as it is. The next thing. Then another thing what we are required to do is, see here, ln of fp minus fc needs to be calculated. Ln of fp minus fc. fc is the constant rate of infiltration. fp is the infiltration rate at any instance of time, which we have already calculated up above. See here, we have already calculated that value. Just a second, I will show you. The fp values are calculated here. I will take these fp values as it is. I keep it here. These are fp values in centimeter per hour. I have calculated. Then what is the value of fc? fc is the constant rate of infiltration. Towards end, the repeating values can be taken as the value of fc. In every problem, the last 2 entries of fp or maybe 3 entries of fp will be identical. You take that as fc, and here fc is taken as 3.24. fc is 3.24. You have to take this. Now, based on this, you calculate fp minus fc. Say that is what we need here as fp minus fc you calculate. So that I would do it here. So it starts from here because we don't have any value here for the first instance. So first value is 21 minus 3.24, that is fc value. The second is 15 minus 3.24. You get this value. Similarly, you calculate for other cases. For the last 2, it will not come because it is anyway 3.24, the constant rate of infiltration. These are the values which you need to look into now. These are the values you need to look into. Now, we have to plot a graph of, you look into log, ln, natural log. Ln stands for natural log. So I would calculate ln fp minus fc. I will calculate that here. This is equal to ln. In Excel, it comes automatically. In calculator also, you have this feature. You can make use of this, calculate. And similarly, for other values also, I would calculate. So the values are calculated. Now, again, go back to the problem here. Time against natural log of fp minus fc need to be done. So time has to be taken in hours. You be very careful about this. Here, time has to be taken in hours. And then the corresponding values of ln, it is natural log. You plot this. If you plot, you need to plot this and it would look like a straight line. You look here. It comes more or less like a straight line. Or the other option for you is, in examination, you plot time on x-axis. Time on x-axis. And then on semi-log sheet, you can plot these values. See, this is on regular normal axis, you will plot time. On semi-log sheet, you will plot this. You take a semi-log sheet, the normal axis is time axis and log axis is fp minus fc. Whereas here, what I have done is that I have converted the two, log and plotted. In the examination, you can also do similar thing. What you can do is that after conversion, on a normal graph sheet, you can go for time and this value. Either way, it is possible. Is it clear? If you just take fp minus fc semi-log sheet, or if you convert that to log and plot, a normal graph sheet would do. So I want you to practice this and then come